that is energy changes its form, that is it changes from kinetic energy to potential energy, but at any point during the motion, the total energy, that is the sum of kinetic energy and potential energy, will remain same. So students, we take a simple example of simple harmonic motion that we have been discussing in the starting lectures as well, that is a mass spring system, and we have proved that a mass spring system executes simple harmonic motion. So we take the same example, and in this example we will prove that energy of the system is constant or same at each point during the motion. So we take a vibrating horizontal mass spring system. So here we have a horizontal mass spring system placed on a smooth horizontal surface. So when no force is applied on it, so it would be the mean position represented by O. So now when we stretch this spring through a distance x, then it starts oscillating. Let's suppose that it has been displaced through distance x, and if it has been displaced to a maximum distance, then obviously it will be known as amplitude, and amplitude is represented by x naught. And we further assume that the mass of this spring is m. So as we are familiar in simple harmonic motion that when the body is vibrating, then during its motion its velocity is maximum at the mean position and minimum at the extreme position. So we can write that its kinetic energy at the extreme position will be 0. We will calculate its value at the mean position after a little while. Now further, at this point, that is at extreme position, the potential energy will be maximum and it will be minimum at the mean position. So we can write potential energy at mean position equal to 0, because at mean position you can see that there is no stretching force on the spring. So if there is no stretching force in the spring, there will be no elastic potential energy stored in the spring. So that's why we take potential energy equal to 0 at the mean position. So now students, we have the two values at of kinetic energy and potential energy, that is at the mean and at the extreme position. Now what we have to do from now onwards, we have to find the value of potential energy at the extreme position. Then we will find the value of kinetic energy at the mean position as well. Then we will find out the sum of these two energies, and we will see that whether those two sums are equal or not. Further students, we take another point, that is between mean and extreme position. That is somewhere between mean and extreme position, let's say at a distance x. So we will find that values of kinetic energy and potential energy at a distance x from the mean position, and we will see whether the sum at this distance is equal to the sum of energies at the mean and extreme position or not. So now students, we have 3 points: extreme position, mean position, and a point between mean and extreme position, and we have to prove that at these 3 points the sum of kinetic energy and potential energy remains same, that is total energy remains same at these 3 points. So students, we start calculating the value of potential energy at the extreme position. Now अब extreme position के ऊपर हम कैसे इसको find out कर सकते हैं? So we have a work energy principle students. According to this principle, work done is equal to change in energy of the body. So we simply calculate the work done in stretching the spring from the mean position to extreme position, and that work will be equal to potential energy stored in the body. So now we have to calculate the work done, and eventually we will get the value of potential energy at extreme position. Now students, in order to calculate work, we need two values, that is force and displacement. Displacement here will be equal to x naught, and first we calculate the force. Now students, since the force is changing as we keep on stretching a spring, then the value of applied force has to be increased. So we have various values of force here, that is the force does not remain constant in this case, so we cannot simply apply the formula W is equal to F dot D or Fd cos theta. So first we have to calculate the average value of F. Now you can see that when displacement is 0, it means that force is also equal to 0. And when displacement becomes equal to x naught, then according to Hooke's law, the force will be equal to kx naught. Now we have the maximum and minimum values of the force, and we can calculate its average value. Now, average force will be equal to 0 plus kx naught divided by 2, and it would be 1 by 2 kx naught. So student, we have the average value of the force, and now we can calculate the work done in stretching the spring from its mean position to extreme position. Now as work done W is equal to Fd, because force and displacement are in the same direction, so we simply take W is equal to Fd. Now substitute the values. F is equal to 1 by 2 kx naught and D is equal to x naught, and we have the work W is equal to 1 by 2 kx naught square. So if this much or this amount of work has been done in displacing the spring from this mean position to extreme position, it means that the energy, the potential energy stored in the spring will be 1 by 2 kx naught square. So this work is stored as maximum potential energy of spring. So we can write hence we have the value of maximum potential energy, and it is equal to 1 by 2 kx naught square. So students, we have the value of potential energy at extreme position, and we can write it here in the diagram as well, 1 by 2 kx naught square. Now what would be the value of this potential energy at this distance x? So we simply replace x naught by x, because the remaining terms are constant, 1 by 2 and k are constant. So it means if we calculate the value of potential energy at this middle point at a distance x, then it would come out to be, now the instantaneous value of potential energy will be equal to 1 by 2 kx square. So we have these two values. Potential energy at extreme position, potential energy at the middle point, that is at this point. We write it here as well, so it's 1 by 2 kx square. Okay students, so now we have to calculate the value of kinetic energy at this middle point and then at mean position. So now kinetic energy at this position will be, as kinetic energy is given by the relation 1 by 2 mv square. Now in simple harmonic motion, this v is equal to, where this v is equal to x naught under root of k by m into 1 minus x square over x naught square. Now this means that kinetic energy can also be written as half m, and substitute the value of v, we have x naught square root of k by m into 1 minus x square divided by x naught square under bracket. We take the whole square. On solving this expression, we will have 1 by 2m x naught square. After cancelling square with square root, we will have k by n into 1 minus x square divided by x naught square. So it can be further simplified as half k x naught square into 1 minus x square divided by x naught square. So here we have the value of kinetic energy at a distance x. So it can be expressed as the instantaneous value of the kinetic energy. So इसको हम encircle कर लेते हैं. So at mean position, this value can also be calculated by substituting x equal to 0. Now at mean position, x is equal to 0. This means that maximum value of kinetic energy will be 1 by 2 k x naught square 1 minus 0 by x naught square. So ये ब्रैकेट वाली टर्म सॉल्व हो गया, हमारे पास 1 रह जाएगी और मैक्सिमम काइनेटिक एनर्जी की वैल्यू हमारे पास आ गई है हाफ के एक्स नॉट स्क्वायर. सो स्टूडेंट्स, हमने सारी वैल्यूज कैलकुलेट कर ली हैं काइनेटिक एनर्जी की और पोटेंशियल एनर्जी की तीनों पॉइंट्स के ऊपर. तो अब हम सिंपली इनका सम ले लेते हैं और देखते हैं कि क्या तीनों पॉइंट्स के ऊपर ये काइनेटिक एनर्जी और पोटेंशियल एनर्जी का सम सेम आ रहा है या नहीं आ रहा है. इन वैल्यूज को हम इधर फिगर में भी देख लेते हैं. मेन पोजीशन पे हमारी काइनेटिक एनर्जी आ गई है 1 by 2 k x naught square और इस मिडिल पॉइंट के ऊपर काइनेटिक एनर्जी है हमारे पास हाफ k x naught square into 1 minus x square by x naught square. Now students, you can see that if we take the sum of kinetic energy and potential energy at the mean position and extreme position, it will be 1 by 2 k x naught square. So ये जो मिडिल वाला पॉइंट है इसमें भी हम इसका सम निकाल के देख लेते हैं कि क्या वो भी 1 by 2 k x naught square आ रहा है या नहीं आ रहा है. So total energy at any instant, इसकी हेडिंग हम दे सकते हैं total energy at any instant. So इसकी वैल्यू क्या आएगी? So ये हमारे पास आ जाएगा total energy is the sum of kinetic energy and potential energy in this case. So it will be kinetic energy हमारे पास है half k x naught square into 1 minus x square by x naught square. And potential energy is equal to potential energy at the middle point is half k x square. If we further simplify this expression, कि हाफ x naught square को अगर 1 से मल्टीप्लाई करते हैं यही एक्सप्रेशन आ जाएगी माइनस हाफ k x naught square मल्टीप्लाई ये x square और x naught square से भी मल्टीप्लाई करते हैं. ये x naught square को x naught square से कैंसिल करें तो हमारे पास बच जाएगा हाफ k x naught square माइनस हाफ k x square माइनस हाफ k x square. So plus, and if we cancel these two values, then we have the value of total energy equal to half k x naught square. So here we have the conservation of total energy in simple harmonic motion, and students, we can see that at all of these 3 points the sum of kinetic energy and potential energy is equal. That is, we can say that the energy remains conserved in simple harmonic. टॉपिक के कंक्लूजन की तरफ आ जाए और कंक्लूजन में हमने अभी देखा कि टोटल एनर्जी इज कंजर्व्ड इन सिंपल हार्मोनिक मोशन और ये हमने अभी मैथमेटिकली 3 पॉइंट्स लिए, तीनों पे टोटल एनर्जी जो है वो यानी काइनेटिक और पोटेंशियल का सम लेके देखा कि वो सेम आ रहा है. फर्दर हमने ये ऑब्जर्व किया कि पोटेंशियल एनर्जी जो है ये मैक्सिमम एक्सट्रीम पोजीशंस पे और मिनिमम है मेन पोजीशन पे. कन्वर्सली काइनेटिक एनर्जी मीन पोजीशन पे मैक्सिमम है और एक्सट्रीम पोजीशन पे ये मिनिमम है। अब ये काइनेटिक और पोटेंशियल का जो आपस में रिलेशन है इसे हम ग्राफिकली भी डिस्प्लेसमेंट एनर्जी डायग्राम से रिप्रेजेंट कर सकते हैं। सो वी हैव डिस्प्लेसमेंट एनर्जी डायग्राम। सो स्टूडेंट्स, इसमें एक्स एक्सिस पे हम डिस्प्लेसमेंट को ले लेते हैं, वाई एक्सिस पे हम एनर्जी, और इसमें हमारे पास ये दो तरह के कर्व्स आ जाएंगे। ये आपने ले ली डिस्प्लेसमेंट माइनस एक्स नॉट और इधर डिस्प्लेसमेंट ले लें प्लस एक्स नॉट। सो ये हमारे पास एक कर्व आ जाएगी, और इस कर्व में आप देखेंगे एक्सट्रीम पोजीशंस पे मैक्सिमम एनर्जी है और मीन पे जीरो है, तो इसका मतलब ये रिप्रेजेंट कर रही है पोटेंशियल एनर्जी को। और इसका उलट जो कर्व बनेगी जिसमें आप देखेंगे कि मीन पे एनर्जी ज्यादा है और एक्सट्रीम पे मिनिमम है, so that would represent kinetic. So here we have the relation between kinetic potential and maximum energy.